Oh, okay. Hello. Hello, chat. All right. Sorry, I was doing a little bit of drawing there and I wasn't talking. Um, so today I want to talk about type 1, type 2 virtualization. And then after talking about it here for the next little bit, I plan to actually draw it out. I mean, not draw it out, but actually do it. So we're going to see type 1 and type 2 virtualization actually happening. And we're going to use one product that's completely free. And one product, it depends on if you have. But I'll talk about there's a couple other options to be able to do some other type 2s. And don't mind me, I'm eating as I go. So, type 1 virtualization, which is what we normally use in like business environments, corporate environments, or anybody who's trying to do like home labs and stuff like that. That's where you'll be on type 1 virtualization. Most of the other time we'll be on type 2. And the big difference between these two is how we're utilizing the resources available. So the RAM, the graphics card, the CPU, all that kind of stuff. So one of the first big takeaways from type 1 is we normally run the operating system of whatever is managing this off an SD card. So it's normally not even running on the actual physical device. That's where we get that bare metal aspect of it, because it's the bare equipment, and we're not having any of the overhead of running the actual operating system. Now, type 2, we're running the operating system. Okay. Undo. Okay. So we're running the OS as a layer, and it's not we have overheads because the OS needs to be able to run. So we're not going to be able to fully utilize all resources of the hardware under type 2. Type 1, we can get very, very finite with that. Okay. So back to type 1. So how do we run the actual... So we need some type of virtualization software or mechanic to actually handle this. So that's why we have the virtualization software. I'm just going to say virt down here. I'll try to spell that out, virtualization software. So in our case, that's kind of, on type 1, we're kind of being overly managed by the OS. And this is kind of the shell base of it, okay? But on type 2, okay, so we have the operating system. So that's the virtualization software there. I know, I'm not really trying to make it fully legible. So again, so you have the type 1, the type 2. See how much more or less space we have to be able to do this. And now we have this mechanic called guest OSs. This is also known as the VM. Okay. On type 1, we can create more VMs and we can utilize more of the resources available to us. So if we have like 16 gigs of RAM, we can get very, very close of using all 16 gigs of RAM for just virtualization. But that's not the same on type 2. So on a type 2, we are limited by 1. Let's say if we had 16 gigs of RAM, the operating system is going to take up at least 4 to 6 of those. So let's say it's 4, so that leaves us with 10. So then the actual virtualization software needs RAM and resources to run. So now we were already down to 12 left over our 16 gigs. That might take up a gig or two because it's a graphical interface. So that only really leaves us with 10 gigs. And that's not even taking into consideration like CPU utilization. By CPU utilization and stuff like that. Under type 2, The more VMs that you're using, the more that your system's going to end up being bogged down. Think about it as if you're running multiple applications that are all CPU intensive. So the more things you're running, the more the operating system has to be able to run that software, and that software running the operating systems inside that software. Type 1, on the other hand, this is designed to be able to fully use. Sorry. Since Type 1 is designed. I took a bite of a chip and it went down the wrong pipe. Sorry about that. Since Type 1 is designed to be able to use the whole 16 gigs, we can get more of it, and we can kind of dedicate RAM specifically for it. So it's not really going to bog down. But we are resource restricted. We can't go over that amount. So what's the purpose of having all these VMs? Sorry, give me 1 second here to cough. Okay, so why do you want all these VMs? Well, think about it as having the ability to have multiple operating systems at your disposal at any given time. I'll talk Type 2 reasons, and I'll talk Type 1. Type 1, it makes more sense. So Type 2, why would you want to be able to do Type 2 and run multiple VMs at the same time? Well, back in the day, we used to do a thing called dual booting, where you would be able to have multiple operating systems on a single hard drive, and then through that aspect of booting, you'd be able to choose which operating system you want to run at that given time. Sounds fun, right? But you always had to reboot to be able to get to the new operating system. So if you wanted to run Windows 7, Windows 10, all on the same machine, every time you want to switch operating systems, you have to change. You have to reboot the machine. But with Type 2, I can have my base operating systems, Windows 10 or Linux, and then I can still have multiple different versions of Linux and multiple different versions of Windows available to me that I can turn on at any given time. And then I get into the aspect that I can sandbox. And this is where you get like the dev stuff and the trial stuff and like people who are trying security stuff going on, because then I can use this virtualization sandbox and it's not going to leak out and potentially cause massive issues to my host operating system. And host is a word that we got to get accustomed to, because whenever we say host, we are talking about the machine's operating system. In most cases, again, because it's like 80% of the market, is probably going to be Windows. So that's kind of the reason why under number 2, we do that. Now, again, number 1 is more based for industry and stuff like that. You can find number 2 happening in industry. There's nothing wrong with that, but it is more efficient to be running a Type 1 versus a Type 2 when you're talking about on a server farm and that kind of stuff. So EXXI is a Type 1 virtualization. That's what we're going to play around with here in a couple of minutes. So why would we run multiple VMs in a bigger environment? Well, you kind of want to have your servers doing different things. You don't want your Active Directory server and your storage server and all these other servers necessarily on the same one, because what if one of them dies? You need backup servers, you need directory servers, database servers. So for every single type of major application that uses some type of database, that's bumping into another server. And then the bigger the organization you are, the more likely you have backups of your backups. So that's the reason why you do it. And then with Type 1, you can just cluster multiple machines together and be able to utilize that same resources. So like, let me rewind. Let's say you have 3 machines that are all exactly the same. You can cluster them together. And instead of having one machine with set capabilities, you can now spread that resources between all 3 machines and use all the power of all 3 machines at one time to do a single task. That's where clustering comes into play. And with virtualization, you can seamlessly kind of move things around a little bit and have this clustered environment. So both are very, very popular. And you're going to see and use both depending on what it is you're individually doing. 2 is definitely better for at-home use because that's probably what most people are going to be doing is if they are doing virtualization. And 1 is definitely industry use. Okay. So let's kind of play around with some of these mechanics. Then we can get a little bit deeper into why we use these things. Okay. The first one I actually want to talk about is Hyper-V. So this is Hyper-V. This is a type 2 virtualization mechanic because it has an application that we're going to use to interact with the virtual machines. Hyper-V is free if you have Windows 10 Pro and above, or you have a server mechanic. Now, there are virtualization softwares if you have less than Windows 10 Pro. VMware Workstation is not free, but it is probably one of the best. And then you also have VBox, which is also fantastic to do. It's completely open source, and they have Linux versions of it too. Okay. As you see right here, I have nothing set up. I haven't built anything on this at all. Hyper-V, if you have a Windows 10 Pro and above, it's a feature turn on. So you just go to Windows features, and the box will show up for you. You just click Hyper-V. Your device will restart, and you'll be able to get to Hyper-V. The mechanics behind it are significantly smoother than it was 5 years ago, and now it's kind of pretty straightforward. Windows really wants people to use Hyper-V, and it is used a lot. VMware is probably the top of the line when we talk about doing virtualization, but Hyper-V is definitely used and will continue to be used. So on Windows 10, we have this fantastic option called Quick Create. So what is this? This is a mechanic built into Windows that allows you to quickly create a virtual machine with Hyper-V without too much having to download anything like that. So in a second here, I can just click that create virtual machine button, and it's going to create one. What's the benefits of Hyper-V? If you have Windows 10 and above, it's built into the system. If you're using Windows Server, it's just part of Windows Server. It's a feature set that you can just turn on. So you're not spending extra money to run it after you are above Windows 10. The downside of it is it does have that initial pay. So if you're running on like standard Windows 10 Home, you're not going to be able to run Hyper-V, and you'll need to look at like VBox. I find the price negligible to move up to it, and it actually is beneficial to move up to Windows 10 Pro if you're using Windows, and if you're in this type of work anyways. If you're looking at this video, then you are already a prime candidate to be running on Windows 10 Pro. Let's be realistic with you. Then you already have this capability built into your operating system, and it works. Sucky thing, though, another kind of negative about any of them, is you can only run one. If you're going to run Hyper-V, then you need to stick with Hyper-V. You can't run multiple virtualization softwares at the same time on the same machine. Now, you can run multiple virtualization softwares across multiple different systems in your environment. That's totally cool. They're all going to integrate together with each other, just not on the same piece of machine. So if I wanted to create one right now, I'm going to do Ubuntu 1910. And as I said, this is about as quick as you possibly can get, and it's meant to just go quickly. And I'll actually probably have to, I'll let this download it, and I'm going to move on to a different one right now. So this is going to sit here and create a Ubuntu 1910 for me. It's going to download the image from the internet, install it, the whole 9 yards. So if we don't want to do quick create, we can just be able to go to the Hyper-V Manager, click New, click Virtual Machines. And I'm going to walk through this process. So our first splash screen is kind of, hey, these are some things that you need to take into consideration. And you can do finish right from the start. That is to create something that has some default values, but we're going to do a little bit more than that. All right. So we're going to get this name. I actually have a server VM that we're going to point this to. So we're going to point this to server 2019. If we want to store this in a different location, we can go ahead and do so. I'm going to leave it in the default location just because of simplicity's sake for myself. All right. Then we need to understand what the difference between generations are. If you're using anything that was designed for the UEF-based BIOS, then you should be on generation 2. So what does that mean? Windows 8 machines and newer of Windows, and then you would have to look at your kernel version to be able to see which version of Linux would have to be under generation 1 or generation 2. But basically, if the machine is using, if the machine was designed to be able to use UEFI, it should be on Gen 2. All right, we're going to dynamically just give it 1024. So we're going to use dynamic memory. And what that means is that we're going to say, hey, you can have this much memory at the start, but only use that to the max. So if you only need 25 to run right now, don't ask for 1024. Doing this will allow us to have more machines running at a time. And then as they ask and let loose of memory, it'll kind of even itself out a little bit. All right, we're just going to do default switch. I'm not going to get into virtual switching mechanics, not in this type of video. All right, so we're going to create a disk. We're going to name it that. This VHDX portion is the type of virtual disk that it is creating. Now, there is a couple other ones, VHDs. VHDX is the most modern one. And, oh, for the life of me, I can't remember what VMware currently uses. All right, go ahead and click next. All right. I already have an ISO. So we're going to go ahead and choose that. Okay. So if we were to choose the option of install operating system later, we can treat this VM exactly the same way as if it was a physical machine. And that's the way you need to interact with this. From this point forward, after I start running any of these, treat that thing as if it's a live operating system on the desktop that you're using. Don't treat it as if it's anything else, because it's not. It's a fully running operating system. Most machines are fully running operating systems. All right. So now I have both that Ubuntu 1910 and that server 2019. And you notice they're both in the off state. So what we're going to do, we're going to power them both on. So what we're seeing right here, this is the kind of the server manager aspect of things. It's telling us what am I capable of doing? What's going on in my machine? How are things being utilized? Now we're gonna let those kind of sit there and sit for a second so I can take a bite of my food. Okay. If you notice the bottom screen right here, that's giving a live view of what's going on inside there. So like in the night, it's at a point in time where it's wanting our attention once we get in there. All right, so let's go ahead and start up So we can just double click on it and we get a nice little window coming up. Oh, and it's saying we have some things that have failed. The boot image is not found. Okay. So I'm going to have to do something with this one. And let that one kind of run. Let's start up that Ubuntu. I'm going to bring this over here. All right. So this is our Ubuntu. We're using something called Remote Desktop right now to interact with this device. Standard Windows 10, Windows Remote Desktop services. This is all this is. And we're going to go ahead and just finish up the installation of this. And we're just going to choose some base English ones. Mainly because we don't want to spend that much time on this. Because I kind of want to get into type 1 virtualization next. All right, what's my name? What's my name? What's my name? What is this? Ubuntu test. Pick a username. Let's do that. Let's do that. Okay. And for my sake right now, I'm going to go ahead and do a login automatic. I would not do this in a production environment. And when we do things later, we will not be doing this. But for our sake of today, yeah. Must start with a lowercase character. Interesting. All right, so we will do bam, 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 bam. Must only contain... What are you not liking? It's the D. Okay. All right, let's continue. All right, so that one's kind of running there. Let's go. I'm going to look at that server one really quickly and see if I can figure out why it crashed. And take another bite of my food. Well, I am probably going to have to change some settings. All right, that's good. Why didn't you boot correctly? All right. Aha, there we go. I'm going to bring this one over here really quickly so you'll be able to see it. So, and there's Windows 2019 server. I'm just going to do a quick next through this. Or as quickly as it's going to let me do. Alright. I do have a product key for this, but I'm not going to use it right now. Because I plan to use that product key on our type 1. Both these type 2s that I'm creating right now is going to get nuked and disappear as soon as I finish with this. Alright, so that's just the standard installation products of getting a Windows server going on there. Alright, and for us over here, we have our Ubuntu help, and that's kind of as far as I want to take that one. Because that gets into talking about Linux, and we might talk about that eventually later. Okay, so I'm going to stop. Alright, not stop. But here are both of them. Both of them are fully running right now. Now, checkpoints is something that you need to think about when we're doing virtual machines. A checkpoint basically is a point in time. So I'm going to checkpoint this guy. All right. And you see how now I have this little second automatic underneath there. So it did an automatic 52740, and now I just did a manual of 533. So I can revert back to that period of time. And it's an exact duplicate of what was going on at that specific state. And that's what makes virtualization so powerful. If you do mess up, you can just revert. You don't have to reinstall operating systems. You don't lose that much work if you're properly doing checkpoints. The problem is you don't want to create so many checkpoints that you're kind of like overdoing your operating system. I've seen people do that where they've taken so many checkpoints, which is also called snapshots, by the way, that you have, you've just done so much. You just saved up so much data that your operating system is just filled with just checkpoints. Okay. So there's the two of them. They're going to go off into the nice little world and be ready for me to talk about the next time I go about doing anything. All right. Where is mouse? Where are you? Okay. All right. So this is the closed screen of that quick connect. And if I were to click this, this is going to open up the VM again. But we don't need that anymore. Okay, so that's type 2. Pretty straightforward, pretty simple. Hyper-V works. If you have the capability of using it, go ahead and just use it. VMware is the preferred, like if you can have VMware licensing, either because you can afford it yourself, which can be expensive, or you have something else going on and you're able to get a copy of it and use it, I would suggest looking into VMware because it is the leading standard in how most virtualization works. Which is why we're going to look at VMware EXSI and creating virtual machines on here now. All right, let me go ahead and log in. All right. Come on. Oh, fine. I'll restart. Come on. There we go. All right. So, what was it? 2 weeks ago, I made this server. This is my EXXI server. And today, we are going to go ahead and create ourselves a couple of VMs on here. And we're going to take a look at how VMs work on this mechanic. All right. And it is slightly different. It's not exactly the same thing. Well, the idea behind it is kind of a lot what we saw in Hyper-V, but we're going to see a little bit different mechanics behind it. Okay. So, this is our kind of our main page, and I can directly create one from here. But first thing, we're actually going to go down to storage, and we're going to kind of look at the database browser here for a second, and kind of do a quick little overview of how we get the ISO here. All right. So I already have a folder that has 3 ISOs on it, and this is a folder that I had to go ahead and create. So I had to initialize a storage location for it, so that the base operating system can read it. And here, if I want to add another operating system to the bank of operating systems, I can just go ahead and click upload, and then I can go to it. Now, I'm going to choose Kali Linux, because I wanted to include Kali Linux as a possible one that's on this this cluster. Okay. Now, if you notice over here on the right-hand side, we got this bar that's moving forward. Once that hits all the way to the right, guess what? Well, the ISO is there, and now we can actually be able to create operating systems directly from here. Okay, and while I was doing that, I'm going to go ahead and take another bite of food. So basically what I'm doing is I'm uploading from my personal host machine and uploading it to this kind of web-based cloud that is the EXXI. And no, if you if the box is showing check marked in there, then Hyper-V is probably already running. Then all you would have to do is kind of Windows key, type in Hyper-V, and that will tell you if it's actually running or not. Okay. And this is basically almost done. All right. EXSI creation of virtual machines. We can do this in two different ways. The mechanic is actually the same. It just depends on how we're going to interact with it. Okay. Our mechanic 1 is we can do it right here at the virtual machine. Our mechanic 2, we can do it at host. Either way will bring us to the exact same screen. Okay. So we're just going to go ahead and do it from this point right here. All right. So we have three options to kind of start out with. Create a new machine, deploy a machine, or register one. All right. Let me talk the bottom two because we're going to do the first one. The very last one, register an existing machine. So you can take a machine, a virtual machine, and transfer it to EXSI. VMware has a mechanic for this. There's a piece of software that you can install, that you can take to a computer, to a server, an operating system, whatever that you want to virtualize. And what it will do is it will copy bit for bit what it is that's on that operating system and send it to the location that you want it to exist in and basically turn it into a virtual machine. And basically you can come here to this option, register an existing virtual machine, and turn it into a VM that can be seen here. Our next one is deploy a virtual machine with an OVF or OVA file. What this means is I can create a file with a set of instructions on it on how I want a VM to be with all the file instructions on it. And then it will run the file with ISO and kind of pre-create it for myself. You will do that if you start talking about cloud stuff or talking about mass creation, and especially useful if you're doing like dev stuff where you might be creating and destroying VMs in the thousands on a constant basis. For our purpose today, we're just going to kind of stay on that create a new virtual machine. All right. So I want to do Ubuntu. So the first machine I'm going to create on here is a Ubuntu machine. Our capability is what version of EXXI is this machine compatible with. All right. I'm going to leave it at the EXXI 7.0 virtual machine. If I was running Workstation and I wanted to bring these two back and forth to each other, I would leave it there, but we're going to go ahead and leave it on 7.0. Then we're going to choose a guest system. Ubuntu is a Linux family. All right. Here's a nice thing. Because they really, really think about this, it has preset instructions to be able to help this system understand what this is. So this is a Ubuntu Linux 64-bit. I can go ahead and choose that. So that means when I move forward, it's going to kind of set this up in a way to be running that way. All right. So we're going to go ahead and tell it where to go. It's already planned to go to that storage device. All right. Here is where we have to start thinking about how we're interacting and how this is going to interact with things. Okay. So first thing we want to do is choose how many CPUs that we want to run on this. Now, I'm not going to go through here and talk about every single piece, every single option that's available to me. But each one of these means something. I'm going to talk about these two right here. The cores in the cores per socket. So a CPU already comes with a certain amount of cores that are sitting on it. And this is same for AMD or Intel. They have so much capability that's already built into their system. But we can choose how many we want this machine to potentially run off of. For our purposes right now, I'm probably going to leave this at a 2 and 2. It doesn't need to be overly advanced, and it's not really going to ever be too much. I'm never going to run like a full scale everything off this system at any given time. More than likely, I'm probably only going to run maybe 3 machines. That's my 3 or 4 machines here. Most of them are going to be pretty small. A little bit of ASMR there as I chew my food. I know. Okay. We can choose how much RAM we want to give. I'm going to stay at kind of a fairly low. This is a Linux machine. And I'm only going to give like 16 gigs of RAM. Meaning that this machine will not grow bigger than 16 gigs. And because I'm not telling it to use dynamic memory, the most RAM that's going to use is 1024. So 1 gig of RAM. Again, it's a Linux machine. You don't really need more than that. All right. We can choose different networks. We only have our one VM network capable. And it's going to utilize... it's going to think that it has USB 2.0 capabilities. All right. Here's where we need to actually choose something. We need to actually point this to our file. So we have that data store. I kind of backed out for it. Status, browse, ISO, Ubuntu, select. Now, this is going to interact with it just if it was a regular computer now. Video card. I can create custom settings for video card. I don't necessarily going to do that here. And I can choose security capabilities. So there are certain capabilities that your hardware has built into it. Okay. I am going to... I did choose an operating system. All right. We're going to review everything, make sure everything is set. All right. Finish. All right. We're going to go ahead and select it. Power this bad boy on. And we're already off to the races. All right. So what do we want to solve? I just want to solve regular Ubuntu. And we're going to let this kind of do its thing for a minute or two. Okay. So this is going to now go through the same process that we saw earlier with that other Ubuntu. And it's going to go ahead and create a Ubuntu at 16 gigs with 1 gig of RAM. And we'll have to do that setup process there at the end of it too to kind of make sure this is all working. Now, because I have a couple other ones that I want to do at the same time, it's going to give me the option already. We're going to go through, we're going to hit install, normal installation, download updates. Continue. This is basic OS installation right here. All right, we're going to go ahead and let that one live. And we're going to go ahead and create ourselves 2 more machines. So we're going to go ahead and create a Kali. Leave it at 7. Linux. All right, so here's going to be an interesting thing. Do we think Kali is going to have its own one on here? It probably doesn't. It probably doesn't. So Kali is based on Debian. And since it's pulling the latest version of it, it's going to be Debian 10. All right, same thing, same disk. If you notice, that free spot has gone down because it allocated that 16 gigs. No, it doesn't really matter which IPv4 address you potentially be using. Uh, the big thing is that you know the username and password, because it's probably going to do dynamic address assigning, DHCP. Just make sure you jot down what the name of it and the address is when it shows it to you. All right, so I'm going to go through the setup process of this one. ISOs, Kali, select. Next, finish. All right, get that one powered on. All right, I have two more that I want to create here. All right, so here we are going to create ourselves a Debian. Or Debian. Why is it showing that? So when you're doing things and you're seeing addresses, like if you notice up over here, I have 192.168.168.86.21. That's an internal address. No one else, someone can't be able to access that address from the exterior because it's a what we call public addresses, and it's not routable across the internet. So if anybody even had this address, they would never be able to access anything on it because they don't know the public addresses that are corresponding to it. So it's completely safe for me to be showing that number. All right, Linux, Debian 10, and we're gonna get this second to last one done. Where is it? I know I say Debian. I know Debian. All right, power that one on. And then we have one more to do. We are going to do a Win19 server. We're going to choose Windows. And we're looking for server 2019. There we go. And we're going to go ahead and enable Windows Virtualization based security. Same issues, leave those all the same. Leave it as 2. And choose our final one. ISOs, Windows, select, and next. And let's get that one powered on. Okay. So now we can kind of check on the progress of each one of these really quickly. So let's go check our Ubuntu. All right. So we have two ways that I can access this. So I can click here and it's going to pop it open. Or I can click here and I can get some different ways that I can interact with it, including opening in a new tab. But I'm just going to click here on this one right now. All right, so we're going to do that. Oh, come on. There we go. We also have the full screen capability if you want it. All right. Continue away. All right, we're going to let that be. We're going to go look at our Kali. All right. We want ourselves a nice little graphics install to be able to see things. And that's off to the races. Let's check our Debian. We notice exactly the same. Let that go off to the races. And then let's check our server. So what is our server complaining about? All right. There we go. Again, you have to treat it exactly the same as if you were, exactly the same way as if it was a real machine. So you have to hit the actual enter button. Yeah, doggo barking. Doggo cute. But doggo barking. Alright, I want to get this Windows 19 to be moving forward. I probably could give this server a little bit more oomph. And I might do that a little bit later. But for today, we're just going to play around with it with low power. Okay. So we kind of have... So we have 4 different options here that we need to be aware of when we're installing Windows Server. Standard Edition, and then Desktop Experience. Then Database, Data Center, and Database Desktop Experience. If you want a GUI, you must select Desktop Experience. I'm going to choose Standard because I don't really want to deal with the... nothing bad with it, but I just want to deal with the Standard Edition, not a Database Center. All right, so that's going to go ahead and install. We're going to go ahead and leave that one for a little bit. Let's go check on our Ubuntu. All right, Ubuntu, get big screen. Where are we? I am... Whoa. No, we're there. Oh, come on. There we go. All right. Let's set this up on here. Yeah, we'll go with that of death. All right. So if you notice, I have a versus the one that we did off of the my personal machine through Type 2. I have an option to directly connect to Active Directory. So this is a big change that has happened in the past couple of years, where we're starting to see Linux machines and Windows machines living in the same environment. So we want to have a little bit more interaction between the two of them. For today, I'm just going to kind of leave that as is. And in the future, when I start talking about Active Directory, we're going to come back with that and play with that. But not today. We just want to log in automatically. All right. We're just going to do a quick look at the other two. See if there's anything I need to do to either of them. Okay. And let's go back and look at here now. So, if you notice, I'm using almost all the memory now. I have a good amount of the CPU, the storage in use, and the CPU utilization is significantly up from running these 4 machines. Now, again, I'm only using a NUC. This is kind of an at-home NUC environment. So it's not going to have a lot of stuff going on with it. But it's enough. It's enough for us to be able to play around and be able to kind of deal with these different machines and kind of do some fun things with them. Okay. I think that is where I wanted to leave off today. When we do come back, and I will come back to this in the future, because the next phase of this, the next thing I kind of want to do is talk about getting an Active Directory up and running in this small environment, and then it's kind of getting these 4 machines to all talk to each other through Active Directory. But for tonight, that's kind of it. I went over what I wanted to went over, and I hope everyone learned some things. So thank you for watching, and in the future, if you're interested, continue to watch. I plan to do a lot more of these because I think this is valuable. All right. Thank you for watching. Have a good night. Bye.